Hi everybody, welcome to another video in Calculus 2, section 8.5, partial fractions. So, of course, partial fraction, we studied this in pre-calculus already. Now it's just a review. However, what we have now is using the partial fraction to decompose an integral, and then we can integrate the little integrals. So, the point here is we try to integrate something like this. If we can break this out into something smaller, then we can integrate little integrals. But before we go to the integration, let's do the partial fraction first. On this section, we use the calculator a lot. So, on that side, make sure you have the calculator there. Right. So, to review in partial fraction, so there might be different cases, but I put everything here. Bottom line is where we have a polynomial can be factored in linear or quadratic factors. It cannot be any higher than that. So when we factor it out, it can be linear or it can be quadratic, meaning that it can be a linear factor or it can be quadratic factor at the bottom. It cannot be a qubit or any higher degree, right? And the quadratic here, it is irreducible, meaning that we cannot factor this into any smaller, right? So either linear or quadratic factor, right? First. Second, if it is a linear factor, the top we're going to have just a constant. If it is quadratic factor, the top is going to be the linear polynomial. So pretty much degree on top is always 1 less than the bottom for that. That's the second. And the last one is, if we have the repeated factor, then we will increase that factor, and then the top, the constant will, or the linear factor, a linear polynomial will be the same degree. So what do I mean by that? So let's look at the first one. Now we just do this one and we just decompose using the coefficient. We do not evaluate the coefficient. Right. So first, when we look at this one is irreducible. This one is irreducible. We cannot factor any further. And we have one factor, one linear factor, and one quadratic factor. For the linear factor, the top is a constant. Quadratic factor, the top is a linear polynomial. So degree on top is 1 less than the bottom. And that's all we do. Later on, we will solve for the coefficient. And after that, we can integrate. But for now, that's all we do. Just get the idea of how do we decompose this. Next, we look at this. 2x plus 2, that irreducible, cannot factor any further. 2x plus 3, that cannot factor any further. The way we can verify that is if we graph a quadratic function, x squared plus 2x, and if we see the graph like this, there is no real solution, so it cannot be factored, right? If it intersects the x-axis, that means it can be factored. This one cannot. So the quadratic factor has to be irreducible. Same thing as the x squared plus 5 earlier. We cannot factor that because x squared plus 5 also do not intersect the x-axis, so cannot be factored. Right. So, and for the linear factor here, there are 3 factors of that. So in that case, we're going to have 3x plus 2, 3x plus 2 square, and 3x plus 2 cube. So there are 3 factors of 3x plus 2, so 1, 2, and 3. Even though the degree at the bottom here increase, we don't change what on the top though? Still just a constant. So doesn't matter what the power is. If it is the same kind of factor, the top is still the same. Right, so there are two of that. Now, for the x squared plus 3x plus 3, there are two of them. So we're going to have 2. And then increase the power. So if this to the 5th power, we have to the 1st, 2nd, 3rd, 4th, and 5th. But the top is still the same thing. We're going to say dx plus e. Degree is 1 less than the bottom. And this will be the same degree. Right. The coefficient can be determined later. So that's the forms. Next, x squared plus 5x plus 4. I suspect that can be factor. So x squared plus 5x plus 4. Right. And we see it intersects at -4 and -1. So it can be factor. So if it can be factor, we have to factor it first, because all the factor at the bottom has to be irreducible. X squared plus 5x plus 4 can factor as x plus 1, x plus 4, and the top will be just x minus 1. Alright, even though it is quadratic, but it can be factor. So if we can factor, we have to factor first. Right. There are two factors of x minus 2. So 1, 2. A factor of x plus 1 and a factor of x plus 4. The top linear factor, so a, this even though a square, still a linear factor. Linear factor. So that's what we have. So if we have a quadratic factor, the top is degree 1 less, so we'll have the linear. Right. So that's how we split it up. Now, next we're going to find the coefficient. And to find the coefficient, there's a couple ways to do that. You can use a calculator, or there's a trick, but could be, depends on the problem, could be more complicated than we can use. Right, first, 1 over x cubed minus 8. X cubed minus 8 is mentioned before. When we factor, it's only linear or quadratic. If it is cubed, it can be factor. So we have to factor if we have degree higher than 2. So that is x cubed minus 8. So that looks like x cubed minus 2 cubed. And this one, just make sure that you have enough space to write very small. X cubed minus 8 is 2 cubed. Right, so we have difference of 2 cubed. First, a review, I'm going to write down the formula here. A difference of 2 cubed is going to be a minus b, a squared plus ab plus b squared. If we have a plus in the middle, the sum of 2 cubed, we're going to have a plus b, a squared minus ab plus b squared. So the sign in the middle here will be the first one. Compared to that, it's going to be the same. The second one is opposite to that. And the last one is always a plus or positive, or we just say it as a plus sign. So that's the difference and the sum of two cubes. Right, so if it can be factored, we can write as 1 over x cubed minus 2 cubed. So x is a, 2 is b, so this x minus 2, x squared, a squared, plus ab, 2 times x, plus b squared, 2 squared, or 4. Right, so that can be written in that form. So if it is written in this form, then we can write that as a polynomial, as a partial fraction, let's just say. If you bring out the note and you write directly on it, try to write small because we need a lot of space here. Right. Now, there's a linear factor. And there's a quadratic factor. When we do the difference of two, or the sum of 2 cubes, this one we cannot be factored anymore. So just have that. Now, linear factor, the top is going to be a constant. For quadratic, the top is 1 degree less. So we have that. Now, from this one, we will multiply both sides by the linear, the least common denominator. So least common denominator is going to be this, and we multiply both sides by that. So it's going to be x minus 2 x squared plus 2x plus 4. So that is the least common denominator. Usually just the denominator of the original fraction. So multiply that to this, the left hand side just 1. Right. Now multiply this to the first part, x minus 2 cancel out, we still have the quadratic factor. So we have a times x squared plus 2x plus 4. And then when we multiply this factor to that, this fraction to this, x squared plus 4 and x squared plus 2x plus 4 cancel out. We have bx plus c and then x minus 2. Now we can multiply this out. Ax squared plus 2ax plus 4a and plus bx squared minus 2bx plus cx minus 2c. Right. There's another way to do this, but for now I'll do this. Next, combine like terms. So there will be 3 terms. First, let's do the x squared. For the x squared, we have x squared and bx squared. Factor out x squared, we have a plus b times x squared. Next, for the x, 2ax, there's an x, and then the x. There are 2a, factor an x out, minus 2b, factor an x out, plus c, factor an x out. And when we do that, the only thing left is 4a and minus 2c, right? So there's a constant here, there's a constant there. I put that in the parentheses as well. Right, so that's good. Multiply them out, combine like terms. Now, we will match on the left. On the left, we only have 1. So, there's no x squared on the left-hand side. That means a plus b has to be equal to 0. Because there's no x squared on the left side. This is called the undetermined coefficient. We're matching the coefficient. There's no x squared on the left, so a plus b has to be equal to 0. There's no x on the left either, so 2a minus 2b plus c have to be 0 as well. 2a minus 2b plus c has to be equal to 0. And then finally, 4a minus 2c is a constant. On the left hand side, the constant, there's a constant 1, so we have 4a minus 2c is equal to 0. Right. So pretty much we will solve this system of equation. Right. We can do that by hand, but I'm going to use the calculator on that side. So I'll go very slow here. So what I'm going to do is I'm going to put this in the matrix form. So let's just rewrite this. I will rewrite this as follows: a plus b, there is no c, equal to 0. 2a minus 2b plus c, that's 0. 4a, no b, minus 2c, equal to 0. Right, so I put that in this form. So a, b, c, constant, I mean coefficient, whatever. So if you put in the matrix, there's 1 for a, 1 for b, 0, and then 0. 2a minus 2b, 1c, and 0. 4a, 0b, minus 2c, and 0. We can put a line here if we want to separate that. So we're going to put that in the calculator in the matrix form, and after that we're going to do reduce row echelon form. Right. So how do we enter the matrix? This matrix has 3 rows, 4 columns. If you're using the TI-84 here, this is how we do it: alpha and zoom. Bottom menu pop up, we have this. So there is 3 rows and 4 columns, and then hit OK. Right. So we do that, we have a 3x4 matrix. Whatever numbers we enter here, do not hit the enter. I repeat, don't hit the enter here until you enter all the numbers. Use the arrow here instead. So first 1, go to next cell 1, then 0, 0, 2, negative 2, 1, and then 0, 4, 0, and negative 2, and then of course I don't know why there's a 1 on the left hand side, right? So this should be 1. So that should be 1. Right. Once we're done, we can hit enter. So that's how we enter the matrix. Right, that's good. But we need to do some operation on it. And the operation is this. You see the matrix above the x to negative 1. Hit second, that button. Go to math. Go down or go to option B that says row, reduce row echelon form or RREF. And we'll just go up, highlight the matrix. I guess we have to highlight that matrix. And we operate on this one. And that turn into this matrix. Hit math, convert to fraction. There. Right? So, let me do this again. Second matrix. Go to math. Go down to option B. And then we can enter the matrix alpha zoom. 3 rows, 4 columns. So that's good. Hit OK. And now enter the numbers. Hit next. 2. -2. 1. 4. -2. And 1. We can change to fraction. There. Right. So when we do that, we will have the matrix 1, 0, 0. We should have the diagonal matrix, the identity matrix on the left side. And what we have on the right is corresponding to A, B, and C. So this is A, B, and C. Right. Now, if we can do this, or we can do the old-fashioned way of the matrix, second matrix, and we can go to edit and hit A, and then 3 by 4. Right. Let me do that again. In the old form of the calculator, we hit second matrix, have to go to edit and input the matrix. Now it has 3 rows, 4 columns. In here we're going to use the enter. In this environment, we're going to use enter to move to the next cell. And I'll do the same thing. 1, 1, 0, 0, 2, -2, 1, 0, 4, 0, -2, and 1. Right. Second mode. So when we hit second matrix, we go to edit to input the matrix, and when we in the first tab we say names, that's where we recall the matrix. Once again, the first tab to recall the matrix, the third tab to input the matrix. Right. The second tab though is where we have the math, the operation, reduce row echelon form. And then we will hit second matrix under the names to recall the matrix. Just hit enter. Now we apply that to matrix A and change that to fraction. Right. So this is called reduce row echelon form. So if you take linear algebra, you study about this a lot more. So bottom line is we have A, B, and C here, and we can put it back into this form. So when we do that, we have just write the original will be equal to A 1/12 B and C. Was that negative one? No, yeah. Right. Yeah. Sorry, take some time for the first one, but just go over the different options on the calculator. Right. On the second one. Before we go any further, before we do anything, we have to be able to factor this one first into irreducible factors. So the top, x squared minus 4x plus 12. The bottom, we can all factor out an x. So we have x squared plus 4x plus 4, which can be factored as x plus 2 and x plus 2, or we can write as x squared minus 4x plus 12 x plus 2 squared. Now, to do this, of course, we're going to decompose the denominator. Right, there's a factor of x. A factor of x plus 2. There's actually two factors of that. So we need 1, 2. Right, the top though, constant, not constant. Right, we'll multiply both sides by the common denominator. This common denominator of x plus 2 squared. Multiply that, we have x squared minus 4x plus 12 equal to just one bit. When we multiply this, the x cancel out. We have a x plus 2 squared. And then b, one factor of x plus 2 cancel out with x plus 2, so we have bx x plus 2, and then x plus 2 cancel out, we have cx. Now multiply this out. X plus 2 square, actually x plus 2 square is x squared plus 4x plus 4, right? Yeah. So if we multiply it out, we're going to have x squared plus 4x plus 4. And then bx squared plus 2bx. And then cx. Right, multiply one more time. Ax squared 4ax 4a bx squared 2bx plus cx. Right. Combine like terms. There's x squared here, x squared there. Factor out x squared, we have a plus b x squared. And then 4ax 2bx and the cx. Factor out x. And then 4a is a constant. Right, the left hand side though, we will have x squared minus 4x plus 12. Right, now we just match the x squared, the coefficient, the whole term here have to match with this, which means a plus b is going to be the coefficient of x squared, which is 1. So first we have a plus b, there's no c there, equal to 1. Next, for a, 2b, and c, that is equal to the negative 4x, and in particular an x cancel out, this must be equal to negative 4. And then finally the 4a must be equal to 12. Right. So I write columns of a, b, and c, and the constant on the other side. So in that case we can put in the matrix and do the reduced row echelon form nicely. 1 for a, 1 for b, 0 for c, equal to 1. 4a, 2b, 1c, equal to negative 4. 4a, 0b, 0c, equal to 12. And do the reduced row echelon form. Second x to negative 1. Second x to negative 1. Go to math and go down to reduce row echelon form, the last one. I mean option B, reduce row echelon form. And we apply to the matrix. Also 3 rows, 4 columns, so that's good. Okay. 1 for A, 1 for B, and then equal to 1. For A, 2B, 1C, equal to negative 4. And 4A equal to 12. So the last one we know A is equal to 3, and then we put back in here, we solve for B, and then we substitute here, we solve for C. So we can do this by hand, but we can also do that. The nice thing about the calculator is it will have a lot more coefficient. We still be able to do this. Whereas when we do it by hand, there's only a few coefficients that we can solve for. When it gets too complicated though, we cannot do that by hand efficiently. By the way, when we do the reduced row echelon form, we have to have the 1 under the diagonal here. We have to have what we call the identity matrix. If we have 0 here, then this is not the answer. But when we have 1, 1, and 1, that is A, B, then C. Then you may ask why is that A and B and C? Well, the way we set it up, first column is A, second column is B, third column is C. When we do that, we're going to have A, B, C. If we interchange the columns here, we're going to interchange the row in the answer. But bottom line is, that's what we have. And then we substitute into this form. Then we have the answer. So from the beginning, it will be factor as A equal to 3x, B is negative 2, and C is negative 12. Right, so that is the partial fraction. It's not difficult, it's just a bit tedious. Right. Next, we're going to do the integral. But before we do the integral, we have to do some very simple integral first. Right, so by the way, I think I left something in the note. So this is first example where we have that. Now this is a very simple substitution. I will let u equal to x plus 8, and then we go from there. So u equal to x plus 8. So du over dx is 1. So du is equal to dx. So just a simple substitution. So here we're going to have 1 over x plus a is u. Dx is du. So integral 1 over u is ln of absolute value of u plus c. So that is ln of absolute value of x plus a plus c. The reason we do this because potentially we might have the factor like that at the bottom. Right, so that's the first one. Potentially we could have that factor square. Right, so we do this example first. So later on when we see the factor like this, we did see the fraction like this, we don't have to do the integral again. Let's just go back to summary here. So we do the same substitution. That equal to integral of 1 over x plus a is u square dx is du. So this equal to u to negative 2 du. Integral of that is u to negative 1 over negative 1 plus c. So which is negative u to negative 1 plus c, and u is x plus a to negative 1 plus c. Right. Next, we're going to have that. Potentially we have a quadratic factor as well. For quadratic factor, irreducible quadratic factor, we can write as this form. Now, this is something square plus that. So actually there's a lot of substitution, but first let's do the simple substitution, and we call that u. So try to write small because it might take some space. Let u equal to x plus a. Same thing here, we already did. If u equal to x plus a, then du is dx. We already did that. So the integral now is equal to 1 over u square plus b square dx is du. So let that be the integral I. Now, a constant square plus a variable square. This is a substitution, so we're going to use the trig substitution. Let u equal to b. In that form, it's going to be tangent theta. Right, take derivative. Is secant square. Move the d theta. And then the u square plus b square. So this is pretty much like the previous section. Where we do trigonometric substitution. U is b tangent. So we have b square tangent square plus b square. Factor out b square, we have tangent square plus 1, which is secant square. Right, now just substitute into the integral. Here we have u square plus b square, which is b square secant square du is this. Right, good thing the secant square cancel out, and there's a b over b square. That constant on the top, b square at the bottom. So when with everything simplified, we don't have anything except b over b square integral of d theta. B over b square is 1 over b, and integral of integral of d theta is just theta plus c. Finally, we just need to solve for theta. Now since u is equal to b tangent theta, if we want to solve for tangent theta, it's going to be u over b. And if we take the inverse on both sides, theta is equal to tangent inverse of u over b. Let's see. And we substitute back into our problem. So the integral equal to 1 over b tangent inverse of theta. I'm sorry, theta is tangent. There's no plus c here, sorry. Theta is tangent inverse of u over b. Then plus c. And u is x plus 8, so we have 1 over b tangent inverse x plus a over b plus c. Right. So potentially we see a bunch of factors like that, and so I'm just going to write in summary, if we have the integral of 1 over x plus a dx, it is going to be ln of x plus a plus c. If we have a square this is going to be equal to negative x plus a to negative 1 plus c, and when we have a quadratic factor, it is equal to 1 over b tangent inverse x plus a over b plus the constant c. Refer back to this whenever we're done with the partial fraction, then we'll just look back to this and we'll just do the problem, right? I'll get back to this soon enough. But now let's go to the first example. Evaluate that integral. So before we do this, we have to be able to break down the integral, break down the fraction, the partial fraction into a little fraction, and then we integrate each little fraction. Alright, first, that one. Let that be the integral I, which we'll do later. For now, first, have to be able to decompose that. Before we decompose it, we have to be able to factor it. X cubed minus 9x squared we can factor out x squared, right? And then we have x minus 9. Right. Now we have x squared, meaning that there's a factor of x and x squared, and then the factor of x minus 9. Linear factor, so a, b, and linear factor c. Multiply both sides by the least common denominator of that x squared. Now we just look at this actually, just those two. So x squared, that cancel out, we just have 3 equal to x times that, so we're left with an x. And then we have x1, x squared cancel out, b x minus 9, and x minus 9 cancel out, we have c x squared. Right, multiply it out to combine like terms. Ax squared minus 9ax plus bx minus 9b plus cx squared. Right, combine like terms. Ax squared and cx squared. There's 9ax. There's bx. And then the constant. Always write a plus like this. Right. The right hand side though, we have 3. 3 is the constant. So we match x squared with x squared, which we don't have any x squared here. X with x, which we don't have anything here. So that's what we can do. A plus c equal to 0 because there's no x squared on this side. So A, there's no B, there's a C equal to 0. There's also no x on this side. Negative 9a. There's a B. There's no C equal to 0. And there's negative 9b. Equal to 3. This one actually we can just solve by hand without any problem. But to do it by hand, actually I'm going to do it a different way. But first, to be consistent, I'm just going to put in the calculator here 1a, no b, 1c equal to 0. Negative 9, 1, 0 equal to 0. 0, negative 9, 0, and 3. Reduce row echelon form. We should have 1, 0, 0, 0, 1, 0, 0, 0, 1. If we don't have this, that means we cannot solve. The system has some either infinitely many solution or no solution. Go to math, reduce row echelon form. Right. Alpha zoom. 3 row, 4 columns. That's good. 1 for A, 1 for C, negative 9, 1, negative 9, and 3. All right. I wish there's something nice and even, but it's not. So negative 1 over 27, negative 1/3, 1 over 27. So A, B, and C. All right. Now, we don't have just a fraction, we have the integral, right? So when we put it back, it's actually an integral of those 3 terms. Right, negative 1 over 27 x plus negative 1/3 x squared plus 1 over 27 x minus 9. Right. Now for this, we can split the integral as follows. Sorry. Split on the integral, take out the constant. Negative 1 over 27, 1 over x dx. Negative 1 over 3, 1 over x squared dx. 1 over 27 1 over x minus 9 dx. Right, so we have that, and that's why we did this earlier. Right, negative 1 over 27 1 over x. Now a is going to be 0 in this case, so 1 over x, sorry. So do this. Now for 1 over x, a is going to be 0, right? Compare this from when a equal to 0. So actually that's just ln of absolute values of x. And then minus 1/3 1 over x squared, it's going to be this, but a equal to 0. So we're going to have negative x plus 8, so just 0 to negative 1. And then plus 1 over 27. That, in this case, where a equal to negative 9. So whenever you do the homework in this section, make sure you have this with you so we don't have to worry about all that. Negative, that's a 1/3 x to negative 1, and then 1 over 27 ln of x minus 9. Let's see. Yeah, so that. Now my focus on is what if we don't want to multiply it out? What if we don't do this and we don't use a calculator? What can we do though? Now I'm focus on here, on that step. Right, there's another way to evaluate, to find the coefficient for the undetermined coefficient in partial fraction. What we can do here is, we see there's a factor of x, or x minus 0, or a factor of x minus 9, right? So in that case, what happens if we let x equal to 0? If we let x equal to 0, this one go to 0, that one go to 0, and we have 3 equal to, I'm just going to say this, a times 0, 0 minus 9, b 0 minus 9, c 0 squared. The reason we choose 0 because that is corresponding to factor of x. We choose x equal to 0. So pretty much we let every factor equal to 0. So that's one gone, that one gone. We have negative 9b equal to 3. So to solve for b, we have b equal to negative 1 over 3. Now, next we're going to let x equal to 9. Because there's a factor of x minus 9. If we let that equal to 0, we have x equal to 9. We're going to substitute in here. 3 equal to a 9 x equal to 9 minus 9 plus b 9 minus 9 plus c 9 squared. So this one go to 0, this one go to 0, and we have 3 equal to 9 squared, which is 81c. So c equal to 3 over 81. So c is equal to 1 over 27. Right. So for those two factors, we can just go ahead and solve for b and c. How do we solve for a? Well, we have 3 variables a, b, and c. We're going to need 3 values here. There's 0 and 9 already. What is the other one? Because in that case, if you don't know, just choose a random values. How about 1? Like I said, I just need another values. This might not be as nice as this, but let's just see. we have 3. Now put 1 in for x. Right, so we have 3 equal to, that is negative 8a plus negative 8b plus c. Alright, as I said, it's not going to be nice. Here we can solve for a. Put the 8 on this side and the 3 on the other side. I run out of space, but the idea here is we already have b and we already have c. We can solve for a. So if we don't have the calculator, this is what we do. Choose some value for x. That simplifies the equation nicely. Usually those values come from the factors. The reason we can do this because the problem is simple enough. If the problem is complicated, I prefer just go with the calculator. But the reason I do the calculator because I want to build the reputation. It just shows that just multiply out, combine like terms. Those are the easy. Just need to be a little careful. And I'll use different marking here so it's easier with the bookkeeping. But other than that, should be simple enough. Right, next we have this one. Right, so before we can go any further for this one, I have to decompose that. Right, so 1 factor of that and 2 factor of that. All linear factors, so just ABCs on top. Simple enough. Right. Now, multiply both sides by the common denominator of this. That cancel out. X plus 2 and x plus 2 cancel out. X plus 1 square. X plus 1, one of the factor of x plus 1 cancel out. We have x plus 2 and x plus 1. And C, x plus 1 cancel out. We have x plus 2. Right, multiply it out, combine like terms. Or we can do it like this, and we're going to choose x equal to negative 1 and x equal to negative 2, and we're going to need 1 more values because 3 variables should have 3 equations. So we can choose x equal to negative 1, x equal to negative 2, and you can choose something like x equal to 0. But like I said, I prefer just multiply it out. X plus 1 square and now this x square plus 2 plus x plus 2x plus 2 and then cx plus 2c. multiply this out, x squared plus x plus another x plus 1. So x squared plus 3x plus 2 right. So ax squared plus 2ax plus a bx squared 3bx 2b cx plus 2c. Right. Combine like terms. Ax squared is x squared a plus b two ax 3bx and cx and then so look like there's a constant here. And then on the left hand side we still have that. Right. So matching coefficient a plus b equal to -4. -14x equal to 2a plus 3b plus c. -14 and then the last one a plus 2b plus 2c equal to 15. Right. Put in the matrix, reduce row echelon form. 1 for A, 1 for B, no C. 2 for A, 3 for B, 1 for C. 1 for A, 2 for B, 2 for C. Right. Second matrix. Go to math. Reduce row echelon form. Alpha, zoom. 3 row, 4 column. That's good. Right. Usually we don't have a lot of coefficient to solve for because that's rather complicated. 1a, 1b, for some reason I put in a calculator but it's not displayed. I have to reset the calculator. Sorry. It just went frozen, I guess. Second matrix. Reduce row echelon form. Alpha zoom. 3 row, 4 column. So that's good. 1 for A, don't hit enter. Next, 1B, -4, 2A, 3B, and 1C equal to -14, 1A, 2B, and 2C equal to 15. Right. I make a mistake somewhere, right? Yeah, if I just copy the problem correctly, that minus 15, right? Sorry about that. That's a minus 15. Right. Just go back up and go down here, change to -15. Right, and it's good to go. Much better. Yeah. So make sure that it's not that difficult. It's just tedious. Right. Oh, I still need that. So that means the original integral can be split in the fraction in this form. So the original integral equal to integral of A is -3, B and C yeah. So from here we can split and take out the constant. Now, when we write like that, it is useful to have the summary previously where we integrate. So we're going to have -3 ln of absolute value of x plus 2. So we're going to use this one here. Yeah. And then ln of x plus 1, and then minus 5 x plus 1. I'm going to use that formula. That turned into a plus. I guess I have to zoom out just a second. Now we see a complete problem. Right. Now, let me write like this first. Right. So that, but we can also write in this form. Remember, in the properties of the log, we can always stack the 3 inside, right? Let's factor out the minus, and then we take the 3 inside. So we have minus ln x plus 2 cubed. We take the minus out. Try to factor the first 2 terms. Both of them have ln, and factor out the minus sign. So this is going to be plus and the ln like this. Ln of a sum, sum of ln is the ln the product, so we can write ln of x plus 2 cubed times x plus 1, and then plus 5 x plus 1 to negative 1 plus c. So we can write like that, because the properties of ln of m plus ln of n is ln of m times n, and we use that properties here. Of course, if it is minus, it is going to be a quotient. So sometimes we see the answer written in this form when we combine the logs. Right. So bottom line is decompose the fraction. Decompose using the partial fraction to break the big integral into a bunch of little integrals. And when we integrate each one of them, and this summary will come in handy. Other than that, it's not that complicated. A bit tedious, but not that bad. Right, we have a couple more samples on this. Right, first we have this one. First, let's decompose the fraction here to x squared plus 3x plus 6 over x squared plus 3x. X cubed plus 3x. We can factor out an x. We have x squared plus 3, which we can decompose x squared plus 3. Right, a linear factor, we're just going to need the constant on the top. Quadratic, we need a linear factor. Right, this multiply top and bottom by the least common denominator of x times x plus 3. Right, multiply it out to x squared plus 3x plus 6, just the top, equal to a. X and x cancel out. X and x cancel out. And then x, forgot to square, sorry. X plus 3 and x plus 3 cancel out. We have bx plus c times x, multiply it out to x squared plus 3x plus 6 ax plus 3a bx squared plus cx. Right, that's simple enough. 2x squared plus 3x plus 6. Now this we don't even need to do that because that's only 4 terms. Bx squared and then a plus cx and 3a. Don't even need any color code here. So x squared and x squared must be the same, so b equal to 2. A plus c coefficient of x has to be 3, and 6 must be equal to 3a. So from here we have a equal to 2, and we can substitute in here. So we have 2 plus c equal to 3, so c equal to 1. Right. Did I miss something? Indeed, I do miss something. X squared, snap. So, sorry, that should be x squared, right? That should be x squared here. And the rest of it doesn't work anymore. Sorry. It's not that difficult, but we just have to be very careful. Sorry. So a plus b x squared plus cx plus 3a. Right, so a plus b equal to 2, c equal to 3, and 3a equal to 6. So obviously c is equal to 3 and a equal to 2. Now put 2 in for a. Should be equal to 2. I mean 0. Once again, sorry about that. It was too easy and I was on cruise control, and yeah, so just need to be extra careful with this. Anyway, so we have that, and substitute back into this form, we have the fraction. A equal to 2, B 0, C 3. Right, and we can split this out. 2 1 over x dx, and then 3 1 over x squared plus 3 dx. Right, of course we can do the quick substitution here, but just refer to the good old formula summary that we did earlier, so we don't have to. Okay, so the formula is here, right? First of all, 1 over x, that gives us 2 ln of x. That's easy. Now compare this formula and that formula. The a, we don't have a. B squared is 3, so b is square root of 3. Yeah, compare these two forms. A is equal to 0 and b equal to square root of 3. Right, compare these two forms. that one and this one. A is 0, b is 3, square root of 3. So the integral is 1 over b. By the way, we still have, don't forget there's the 3 here. 1 over b, which is square root of 3, tangent inverse x plus a is 0, and b square root of 3. So it's not that bad. Like I said, when you do this problem, make sure you have those formulas handy so you can just refer it back, and so we don't have to do that every single time. Yeah, so once again, be extra careful with the partial fraction. And then we can simplify 3 over square root of 3 and square root of 3. So we have 2 ln of x plus square root of 3 tangent inverse of x over square root of 3 each page number. Right, so that's what we have. So it's not that bad. So to work it out, if we have the quadratic factor, just go back, refer to the summary where we have the integral of each one of them. Right, so let me zoom out again so we see the whole problem. Right, we have one more example, also the same thing. Do partial fraction. Wow. Right, partial fraction first. Right, first, x squared minus 2x plus 3, is that irreducible? Right, the graph, right, does not intercept the x-axis, so cannot be factored, so it is irreducible. Right, so we're going to have 7x squared minus 13x plus 13 divided by x squared minus 2x plus 3, and then the x minus 2. Right, so we have that. Now, there's just a factor of x minus 2 and the factor of x squared minus 2x plus 3. Actually, this one, the partial fraction is simple. We just have a here and quadratic bx plus c. Right, just go ahead and partial fraction. Multiply top and bottom by the least common denominator of x minus 2, x squared minus 2x plus 3. 7x squared minus 13x plus 13 equal to x minus 2 cancel out. We have x squared minus 2x plus 3. And then when we cancel that out, we have x minus 2 left. Multiply it out. Ax squared minus 2ax plus 3a plus bx squared minus 2bx plus cx minus 2c. Right. Those are x squared and these are x and then for the constant 3a negative 2c x squared minus 13x plus 13. Right, just match the coefficient x squared with that. Don't even need to box it. So, but a plus b equal to 7. For x, negative 2a, negative 2b, and c, and then 3a, no b, 2c equal to 13. Right. 1a, 1b, 7, negative 2, negative 2, 1, 3a, 0, negative 2, and 13. Reduce row-echelon form. Right, hopefully that turned out to be something nice and even, because the problem seemed very complicated. Right, so second matrix, math, reduce row-echelon form, alpha zoom, 3 rows, 4 columns. That's good. 1, 1, 7. If this is more complicated, then we might have a few more coefficients, but like I said, this is complicated enough. Also, when we use the negative sign, I should mention this way before. Use this negative sign and don't use the subtract. This is subtraction, show link between two numbers. This is just negative sign. I should mention that before. 3, negative 2, and 13. Right. Luckily, that turned out to be something nice and even. Right. So with that, we can A, B, and C. We can decompose that original fraction. Right, in that form. A is 5. Right, that's simple, right? And then B, 2x plus C over x squared minus 2x plus 3. and then we can split this up. Factor out of 5. Right now, there's a big problem. Certainly, that's one easy to do. How do we do this? Right. In order to do this, remember, this we cannot factor, right? If we cannot factor, what can we do? Right? By the way, if it is irreducing factor, we should be able to write that in this form: x plus a squared plus b squared. So in that case, what we need to do here is completing square for x squared plus 2x plus 3. So this step is called a completing square. We start with x squared minus 2x plus 3. Right. It is going to be, if we do that, this equal to going to be something square plus something, and x and plus or minus something square and then something square. So we turn into that. So first, what I do is I'm going to say x squared minus 2x. I'm going to add something here to make it into a perfect square. If we add something there, later on we have to subtract the same thing to make it balanced. Right. Now, to determine this, so let's look at a square in general. Let's say if we have that, or let's say x plus a squared. If we multiply this out, we have x squared plus 2ax plus a squared. Right? So just like x plus a times x plus 8 should have that. Now, what we see here is the coefficient here without an x. If we take half of that and then we square it, will get us that third term. So we're going to have take this number, half that, and then we're going to square it. Half of -2 is -1, and -1 squared is 1. So we're going to add 1. -1 squared is +1. And the nice thing about this is, whatever that number we have, just put x in front of it and make a square. And we have those three terms. It's a complete square. 3 minus 1 is 2. So that is the completing square of that one. I'm going to put it back into that. So the integral now becomes 5 and then to x plus 1, I will write it as x minus 1 right. So completing square we write like this. By the way, if we want to, we can write square root of 2 square. Right, that's not the problem. Because when we write like that, we have this form. Now, talk about this form. The top is just 1, right? We still have x. That is the big problem. Right, really, really big problem. So what we will do here is, have to do something here. So if we have just 1 on the top, we can use the formula we just have, right? But we don't have that. We still have an x. And we cannot just split it like this. Splitting like this does not help at all. We have to split this in the special way though. A special way when we split this is we need to keep the x minus 1. Why do we do that? We see in the next problem. We will see in the problem. So what we do here, sorry everybody, there's a problem at the middle of this problem, and so when it did not record the rest of the problem, so we stop the video at this step. So we will continue here. Right. So what we do here is we try to split this term. By the way, I should zoom in so we see the it's better. Just a second. Right. So what I trying to do is we try to split this into the statistic way. We cannot just split in the middle of 2x and then plus 1. It's not going to help. What actually we split, since we have x minus 1 at the bottom, we try to keep the x minus 1 on top. So pay attention closely on the numerator. So I'm going to need to have the x minus 1. So we're going to have x. Originally there's x already, but we need the minus 1 here. Now 2 times x, 2x, 2 times minus 1, minus 2. We cannot just minus 2 it like that without adding a 2. Plus 1. So what we have is split like that. 2x minus 2, 2 plus 2 cancel out. Give it back to that. Now where we split is we split that, and then we have 2 plus 1, which is 3. So we have 2x minus 1 over x minus 1 square plus 2. And then dx, and then we have 3 over x minus 1 square plus 2 dx. Now this one's easy. We have those formulas that summarize into here. When the top is constant, that easy, right? Just going to copy this. Anyway, just worry about this later. That's actually very easy to do. This also very easy. That's the first part of it. That one is this integral. So it's the first one and the last one is easy. Now for the bottom though, what do we let equal to u? Now we can let u equal to x minus 1, and then we do that. But on this one, the reason we write like x minus 1 like this, because if we let u equal to the whole thing at the denominator here, the top works out perfectly, right? But if you don't see that right away, I'm going to do that in 2 steps. By the way, we can just let u equal to x minus 1 square plus 2, the whole denominator here. We can do that. So if we let u equal to x minus 1 square plus 2, derivative is going to be 2x minus 1, which is this. So it turned out to be extremely nice. But sometimes we don't see this right away, so I just make 2 substitutions. First, I'm just going to let u equal to x minus 1, then take derivative, move the dx, and then substitute back in. Right. The first integral is still 1 over x minus 2 dx. Now x minus 2 is u. X minus 1 once again is u. And then the bottom we have, I will write like this instead. Take the 3 outside. And then at the bottom, I write x minus 1 square plus square root of 2 square. So it will be right the form of the integral. And integral of this is 5 ln of x minus 2. So that's easy. Now, this one actually is not that bad. We can just use the substitution. Let v equal to the bottom, and then the top is derivative of that. By the way, this will be 3 1 over square root of 2 tangent inverse x minus 1 over square root of 2 plus c. Once again, we use that, where a is minus 1 and b is square root of 2. Just substitute into that form and we have it. Right, the middle one though, substitution once again. Let v equal to u square plus 2. dv over du is 2u. So dv is 2u du. And dv over 2u is du. I substitute that in here. If u square plus 2 is v dx. Wait, when we do this, actually dx is du already. And du is dv over 2u, which cancel out. Right, and 1 over v, integral 1 over v is ln of v. Ln of absolute value of v plus 3 square root of 2 tangent of 2 tangent inverse x minus 1 over square root of 2 plus c. And finally v is u square plus 2 and u is x minus 1. So substitute it back in, we have 5 ln of x minus 2 ln of x minus 1 square plus 2 plus 3 over square root of 2 tangent inverse of x minus 1 over square root of 2 plus c. Now the nice thing about this is x squared minus 1 squared plus 2. This is always positive, so we just use the bracket instead of absolute values. Alright, so like I said, there is the technical difficulty, and this, I actually did that before. I did that, but for some reason it did not record it, so I have to do this again. Right, so partial fraction, we already have that. When we do the partial fraction, we end up with that. So if it is irreducible, we should be able to do the completion square. When we do that, we have this. Now the trick here is when we see that, we have to split that in a special way, and we'll split that so that we have the same as the bottom of x minus 1. So we try to make x minus 1 on the top. I switch that and do the substitution, and then so that part works out differently than this part. This part is the tangent inverse, which we have on the problem later on. We have already. That's not a problem. Right. So with that, so then we start with. Let me try to zoom out and trying to see the whole problem. Right. So we start with that, and then we continue. Right. With that, I stop the video here. See you in another video in Calculus 2. As always, thank you for watching.